In the grand, enigmatic waltz of the cosmos, our solar system presents itself as a peculiar ensemble, a composition so distinct and idiosyncratic that it stands in stark contrast to the myriad planetary systems strewn across the vast tapestry of the galaxy. It's as though our solar system sings in a peculiar key, resonating with notes of exception rather than conformity. To unravel this cosmic conundrum, scientists embark on a journey akin to peeling the layers of an ancient celestial manuscript. They delve into the cryptic annals of our solar system's clandestine history, seeking whispers and shadows of a time long vanished. What they find is a narrative not of tranquil formation and serene evolution, but of a dark and tumultuous saga. A tale of planetary homicide on a scale so immense it defies the imagination. This narrative of celestial violence is not merely a tale of destruction, but also one of creation and resilience. It's a story etched into the very fabric of our planets, moons, and the asteroid belt, a testament to a time when our cosmic neighborhood was a theater of cosmic collisions and celestial upheavals. The planets, as we know them today, are survivors of this cosmic ballet. Their current orbits, compositions, and even the existence of life on Earth, a direct consequence of this primordial epoch of chaos and creation. In this cosmic detective story, each clue unraveled leads to more profound questions, each discovery a doorway to deeper mysteries. As scientists peer back across the eons, they seek not just to understand the peculiarities of our solar system, but to place our existence within the grand, unending symphony of the universe. For in understanding the violent origins of our celestial home, we may also come to understand the fragile yet tenacious nature of life itself, clinging to a pale blue dot in the vast cosmic sea. In the vast cosmos, our solar system lingers like a spectral echo of its former self, a haunting remnant of cosmic grandeur that once was. It's as if the universe has chosen to preserve a handful of celestial oddities, relics of a time long forgotten. Among these cosmic curiosities, our beloved Earth resides, a peculiar gem that may very well be one of these cosmic anomalies. The very ground we tread upon whispers tales of ancient celestial bodies, now extinct, their stories etched into the fabric of our planet. These long-vanished worlds, it is speculated, may hold the clandestine key to the profound mystery of life's genesis on Earth. Nestled within the spiraling embrace of the Milky Way, our solar system performs its cosmic dance. For countless millennia, humanity gazed upon the heavens, believing our celestial neighborhood to be the universe's sole architectural marvel. This belief stood unchallenged until the relentless pursuit of knowledge led us to a breathtaking revelation. Astronomers have unveiled over 4,000 planetary systems to date, each a unique tapestry of worlds and wonders. But amidst this celestial multitude, our solar system stands apart. The pursuit of astronomy is like peering through a looking glass, only to realize the reflection staring back bears little resemblance to what was once familiar. This cosmic introspection has led to a startling epiphany. Our solar system, with its orderly arrangement and peculiar characteristics, is not the cosmic standard, but an exception. The majority of newfound solar systems bear little resemblance to our own, each flaunting its unique cosmic arrangement, challenging our preconceptions and expanding our understanding of the possible architectures of planetary systems. This realization is not merely an astronomical observation, it is a profound reflection on our place in the cosmos. The discovery that our solar system is an oddity in the vast expanse of the universe compels us to re-evaluate our cosmic origins. It beckons us to ponder the intricate tapestry of cosmic forces that sculpted our celestial home into the unique haven it is today, nurturing the delicate bloom of life on the blue orb we call Earth. In February 2017, NASA unveiled a revelation that would redefine our cosmic perspective. The announcement centered around an enigmatic system nestled within the Aquarius constellation, known by the moniker TRAPPIST-1. This celestial entity, a star not unlike our own Sun, albeit with its own set of peculiarities, captured the imagination of astronomers. TRAPPIST-1 is a touch smaller and cooler than our Sun, yet it cradles a family of 7 planets in its tender, stellar embrace. At first glance, one might shrug at the number, considering our own solar system houses 8. However, a closer look reveals a startling uniformity. These are 7 planets, each roughly the size of Earth, a rare congregation of terrestrial worlds in the cosmic expanse. But the peculiarity does not end there. These celestial siblings dance an intimate ballet around their star, each orbiting closer to TRAPPIST-1 than Mercury does to the Sun. This proximity presents a cosmic conundrum, a puzzle that has perplexed astronomers since the dawn of exoplanetary discovery. The norm, it seems, is for planets to huddle extraordinarily close to their stars, far inside the orbital path of our own Mercury. This observation beckons a haunting question. Why does our solar system appear hollowed out, devoid of planets in the sweltering proximity to the Sun? The enigma of these absent inner planets transforms astrophysicists into cosmic detectives. This cosmic detective work, a blend of science and imagination, probes the depths of our understanding, challenging us to unravel the narrative of our solar system's genesis. The early solar system, in this grand cosmic narrative, is likened to a cosmic billiards game. Each billiard ball, a metaphor for the primordial planetesimals, the embryonic seeds from which planets are born. According to the classical model of planetary formation, these cosmic building blocks collided and coalesced, growing incrementally over eons. In this celestial arena, each planet voraciously accreted material from its immediate surroundings, a localized process of cosmic construction that left the architecture of our solar system as we observe it today. The classical model of planetary formation stands as a time-honored script, detailing the celestial choreography of cosmic bodies. But this venerable model, while eloquent in its simplicity, falters when faced with the void within our inner solar system. It offers no solace, no neatly wrapped explanation for the stark absence of material inward of Mercury's lonely orbit. The region that should be a bustling hub of cosmic activity is instead a silent, empty expanse, a void that the classical model observes with puzzled eyes. This mystery deepens when we consider not just the absence of minor celestial bodies, such as asteroids, but the absence of colossal giants as well. The early chapters of exoplanetary discovery were marked by the unveiling of alien worlds of staggering proportions. These were not humble, rocky planets, but gas giants, behemoths with masses rivaling or surpassing that of our own Jupiter, found in scorching proximity to their parent stars. These hot Jupiters, as they came to be known, presented a cosmic paradox. Traditional understanding dictates that gas giants are born in the frigid outskirts of their star systems, far from the searing heat of their suns. Yet here they were, defying expectations, nestled in orbits tighter than Mercury's embrace of our Sun. The discovery of these approximately 300 hot Jupiters ignited a flurry of questions. How could these gas giants exist in such blistering proximity to their stars, where the relentless heat would seemingly defy the very process of their formation? The temperatures in these close orbits are so extreme that it's difficult to fathom any material coalescing from the solar nebula, the primordial cloud from which stars and planets are born. This conundrum led to a revolutionary shift in perspective, a theory that these hot Jupiters might not have always been so close to their fiery stars. Perhaps, like celestial wanderers, they formed in the distant, cooler reaches of their star systems, similar to the position of our own Jupiter. Then, driven by forces yet fully understood, these gas giants embarked on an inward migration, a grand procession towards their stars. This hypothesis of planetary migration opens a tantalizing possibility. Could such a journey of a Jupiter-sized planet towards its star shed light on the inner solar system's missing mass? Might the inward trek of such a colossal body help unravel the mystery of why our own solar system lacks a hot Jupiter and why the space inward of Mercury is a barren wasteland? A team led by the astute Kevin Walsh embarked on a virtual odyssey to unravel the mysteries of our solar system's nascent years. Their tool of choice was not a telescope, but a sophisticated simulation, a digital time machine designed to rewind the cosmic clock by 10 million years. This ambitious project was christened the Grand Tack Model, a theoretical scenario meticulously crafted to shed light on the formative years of the threshold planets, those rocky worlds including our own Earth. The stage for this grand cosmic drama is set within a dense, swirling disk of gas and debris, the cradle of our newly formed sun. Here, the Grand Tack Model breathes life into a captivating narrative, one where Jupiter, the gas giant with its immense gravitational might, embarks on a celestial voyage through this primordial disk. As it moves, it acts as a cosmic shepherd, herding asteroids and debris in its wake, corralling the raw materials destined to coalesce into the rocky planets of the inner solar system. Jupiter's journey is not a solitary one. As it traverses the disk, its gravitational pull gathers a growing entourage of material, forming a dense, trailing wave of debris. This bulging wave exerts a relentless pressure, propelling Jupiter further inward towards the Sun. In this scenario, Jupiter is akin to a cosmic wrecking ball, poised to clear out the planet-building material from the inner solar system, potentially transforming into a sun-hugging hot Jupiter, a fate observed in many distant star systems. Yet, in this cosmic narrative, Jupiter's inward march is halted, its path of destruction checked by an unforeseen force. If Jupiter had lingered in the inner solar system, the stage where Earth now thrives would have been swept barren. The savior in this celestial tale is none other than Saturn, Jupiter's lesser-known but formidable sibling. Emerging shortly after Jupiter, Saturn follows in the gas giant's cosmic footsteps, its own migration towards the Sun, setting the stage for a dramatic cosmic intervention. As Saturn gains mass and asserts its presence, the dynamics of the gas disk, the cosmic dance floor for these planetary giants, begins to shift. The combined gravitational choreography of Jupiter and Saturn alters the fabric of the disk itself, halting Jupiter's inward journey. In a celestial maneuver reminiscent of a sailboat tacking against the wind, Jupiter changes course, veering away from the Sun, pulled back towards the outer reaches of the solar system by Saturn's timely intervention. This grand cosmic ballet, choreographed by the gravitational interplay of Jupiter and Saturn, leaves an indelible mark on the solar system. The inner region, once a potential home for a hot Jupiter, is left devoid of such a gas giant, its fate dramatically altered. As Jupiter retraces its path outward, it sculpts the inner solar system, its gravitational might stripping away material, leaving behind a narrow band where the rocky planets, including our own Earth, eventually emerge. In this cosmic saga, the Grand Tack Model offers a glimpse into the tumultuous early years of our solar system, a tale of planetary migrations and celestial interactions that shape the familiar yet unique cosmic neighborhood we call home. In the narrative woven by the Grand Tack Model, Jupiter emerges not merely as a colossal gas giant, but as a cosmic architect, its gravitational influence sculpting the very fabric of our solar system. According to this scenario, the rocky terrestrial planets, Earth included, owe their very existence to the intricate cosmic dance performed by Jupiter. But the tale does not end with Jupiter's monumental role. Saturn, often overshadowed by its larger sibling, plays a crucial part in this cosmic ballet. Had Jupiter continued its inward trajectory, drawn inexorably towards the Sun, the stage upon which humanity now thrives might have remained forever barren. The Grand Tack Model offers a compelling chapter in the saga of Earth's formation, shedding light on the absence of a hot Jupiter in our celestial neighborhood. However, it leaves certain mysteries tantalizingly unsolved. The void between Mercury and the Sun remains an enigmatic expanse, devoid of the material and celestial bodies one might expect to find. Moreover, our solar system seems to lack a particular character that is surprisingly common across the galaxy: the super-Earth, a colossal rocky world whose mass can be up to 10 times that of our own planet. Leading the cosmic quest to uncover these distant worlds is the Kepler Space Telescope, a sentinel in the search for exoplanets. With over 2,600 new worlds confirmed, Kepler has revealed that more than a third of these distant planets are super-Earths. These enigmatic planets, with their mass several times that of Earth, are scattered throughout the galaxy, a common thread in the fabric of countless star systems. But in the grand tapestry of our own solar system, this thread is conspicuously absent. The question looms large: why does our celestial neighborhood lack a super-Earth? What cosmic quirk makes our solar system an outlier in this galactic trend? The mass distribution of planets within our solar system presents its own set of cosmic curiosities. From the diminutive Mercury to the colossal Jupiter, the range is vast. The leap in mass from Earth to Uranus is not a gentle incline, but a steep climb from 1 to a dozen times Earth's mass. This stark disparity in planetary sizes, the absence of any world within the super-Earth size range, poses a profound question. Why does this gap exist? What cosmic narrative, what series of celestial events led to this peculiar arrangement of planetary masses within our solar system? In the year 2015, Konstantin Batygin embarked on a quest to decipher the enigmatic absence of super-Earths in our solar system and the void within Mercury's orbit. He revisited the Grand TAC model, infusing it with a novel twist. His simulations birthed a scenario where 6 super-Earths, similar to those observed in distant star systems, orbited tightly around the Sun, a crowded dance of celestial giants at the heart of our solar system. This innovative scenario was aptly named the Grand Attack Model. The Grand Attack Model paints a vivid picture of cosmic upheaval, a narrative where Jupiter's migration is not just a journey, but a cataclysmic event, a veritable grand attack upon the inner sanctum of the solar system. In this model, Jupiter's gravitational influence is magnified, transforming it into a celestial juggernaut that hurls a swarm of giant asteroids and planetary embryos into the inner solar system. These bodies, locked in tight, overlapping orbits, set the stage for a cosmic spectacle of unparalleled proportions. The result is nothing short of celestial carnage. The model predicts a relentless barrage of collisions, each massive body clashing with another every 20 to 200 orbits, a blink of an eye in the cosmic timescale. This frenzied ballet of destruction shatters the overlapping population of celestial bodies into a cloud of smaller debris. Jupiter plays the role of a cosmic catalyst, instigating violent collisions among the debris it gathers in its wake. These monumental clashes birth a sea of minuscule fragments, which, under the influence of the gaseous drag from the Sun's surrounding disk, begin a rapid inward drift. These planetesimals, now reduced to gravel-sized remnants, face the dense gas cloud encircling the Sun. The momentum that once sustained their orbits dissipates, and they begin a spiraling descent, but their journey is fraught with obstacles. As this tidal wave of debris surges inward, it encounters the formidable presence of the super-Earths, celestial dams resisting the relentless flow. But even these giants cannot withstand the tide forever. The accumulated debris exerts an overwhelming pressure, and in a dramatic cosmic cascade, the super-Earths begin their inexorable retreat, dragged towards the Sun's incandescent surface alongside the swirling maelstrom of collisional debris. This cosmic cataclysm unfolds with astonishing swiftness. Within a mere 20,000 years, a cosmic heartbeat, the super-Earths succumb to their fiery fate, plunging into the Sun. The aftermath of this dramatic evolution leaves the inner solar system a shadow of its former self, a mere fraction of its original mass remaining. In the wake of this cosmic upheaval, our solar system stands as a spectral echo of its past, a haunting testament to the tumultuous forces that shaped its destiny. In our immediate expanse, a mere 39 million miles from the Sun, a profound silence reigns. This void marks the beginning of a tale of creation and destruction. Just beyond this emptiness lies a narrow ring of rocky debris. This belt, composed of a mere 10% of the original material once swept in by Jupiter's insatiable gravitational pull, holds the seeds of rebirth for the inner solar system. Amidst this cosmic rubble, a few resilient survivors, small planetesimals, begin a slow and deliberate dance of reformation. Over the span of millions of years, a quartet of small rocky planets emerges from the cosmic dust. Mercury, Venus, Earth, and Mars are born from the remnants of a celestial past. The very ground upon which we stand, the cradle of our existence, may not be a relic of the solar system's first generation. The air we breathe and the soil beneath our feet whisper tales of long-dead stars and planets. Our Earth may very well be a second-generation planet, a child of the wreckage left by the Grand Attack. The super-Earths, those colossal predecessors, took with them more than just their physical form when they met their fiery demise. They carried away the abundant supply of hydrogen and helium that once graced the inner solar system. Today, when we gaze upon our atmosphere devoid of these primordial gases, we witness the legacy of this cosmic event. The composition of the air that envelops us, the very breath of our planet, is a testament to our status as a second-generation world. Being second in the cosmic order might not seem prestigious at first glance, but in this cosmic context, coming in second might very well be the reason for our existence. The Earth we inhabit, Earth 2.0, is a world reborn from cosmic turmoil, a planet whose very atmosphere, a fertile blend of gases, nurtures the building blocks of life. Had Earth been a first-generation planet swathed in an atmosphere rich in hydrogen and helium, the story of life as we know it might have remained untold. This revelation beckons us to ponder the uniqueness of our planet in the vast cosmic theatre. Could it be that life, in its myriad forms, requires the crucible of a second-generation planet to emerge? To unearth the secret history of our cosmic neighborhood, we must venture into the uncharted territories of the universe, seeking the last vestiges of the cataclysmic events that gave birth to our home. Our solar system stands as a celestial cold case, its violent past shrouded in the silence of the cosmos, leaving behind only faint traces of its tumultuous beginnings. This is the challenge that faces us as we strive to decipher the events that unfolded 4.5 billion years ago. It's a daunting task, a puzzle of cosmic proportions that demands not only keen insight, but also a stroke of luck. In this quest for understanding, solid evidence is elusive, a treasure hidden in the depths of space and time. We lack a time machine to transport us back to the dawn of the solar system, to witness firsthand the celestial ballet that set the stage for our existence. However, nature has bestowed upon us time capsules from this ancient era, precious relics that we know as meteorites. Most meteorites are fragments of asteroids, cosmic debris that plummets to Earth from the vastness of space. These celestial remnants come in a variety of shapes and sizes, each telling a unique story of its origin. Asteroids are like space fossils, relics of a time long past. Formed 4.5 billion years ago, they have remained virtually unchanged, untouched by the relentless march of time. They are the leftovers of planetary formation, the final pieces of the cosmic puzzle that did not coalesce into planets. To truly appreciate the significance of meteorites as clues to our solar system's origins, we must first understand the process of planetary formation, a cosmic phenomenon known as accretion. In the swirling maelstrom of hot gas that surrounded the nascent sun, matter began to condense and clump together, forming larger and larger bodies. Within meteorites, we find the remnants of this primordial process in the form of tiny mineral beads known as chondrules. These chondrules are the very seeds of the structure of our solar system, the embryonic building blocks from which the celestial tapestry was woven. Chondrules, often poetically described as droplets of fiery rain that solidified, are globules of silicate melt formed in the earliest history of our solar system. These tiny spheres, once molten and now frozen in time, offer a glimpse into the process of agglomeration, the cosmic process of smaller objects coming together to form larger bodies. Yet some chondrules bear witness to not only the birth of planets, but also their demise, encapsulating the dual narratives of creation and destruction that define our cosmic origins. These meteorites serve as invaluable time capsules, offering us a tangible connection to the distant past. They are the silent witnesses to the birth of our solar system, the keepers of secrets that we are only beginning to unravel. In the cosmic tapestry of our solar system's history, a meteorite named Gujba serves as a silent witness to the celestial tumult of the past. This enigmatic stone is composed of an extraordinary assembly of spherules, each telling a tale of cosmic violence and creation. Gujba is not your ordinary space rock. It's a repository of secrets, harboring both silicate and iron-nickel globules within its ancient, weathered crust. This unique composition makes Gujba a cosmic anomaly, a relic of a time from the early solar system. The metallic spherules nestled within Gujba are thought to have formed some 5 or 6 million years after the solar system's birth, a time when the hot gas of the primordial disk had thinned, no longer capable of forming the chondrules typically seen in such meteorites. The question then arises, how did these globules come into being? The answer lies in a process of unimaginable violence, a scenario where cosmic collisions were so intense that they vaporized both silicates and metals, transforming solid into gas, and then, as the tumult subsided, gas into liquid. But what kind of celestial behemoth could harbor enough metal to give rise to the droplets we observe in Gujba? Only a planetary body of significant stature, one with a heart of iron, could be the progenitor of such cosmic debris. When a celestial body reaches a certain critical mass, its gravity orchestrates a cosmic symphony of separation. This process, known as differentiation, sees the denser materials, like iron and nickel, drawn inexorably towards the core, while the lighter, rocky silicates float upwards, forming a distinct crust. Earth, our own home, is a prime example of such a differentiated body, its structure a testament to this gravitational sorting, with a molten silicate mantle lying between the iron core and the rocky crust. Gujba, then, is not merely a meteorite. It's a testament to the existence of large, differentiated planetary bodies that once roamed our solar system. These celestial giants collided with such force that they scattered their remnants across the cosmos, leaving behind clues in the form of meteorites like Gujba. The story Gujba tells is one of a solar system where differentiated planets were not the exception, but the norm, mere 5 million years post-formation. The frequency of these planetary behemoths was such that cataclysmic collisions were commonplace, a cosmic demolition derby on an unimaginable scale. If we follow this path of planetary formation marked by giant impacts and celestial destruction, we arrive at a startling conclusion. The inner solar system, as we know it, was built not just from cosmic dust and gas, but from the remnants of these past generations, from the debris of countless planetary collisions. Simulations suggest that to construct the inner sanctum of our solar system, a minimum of 30 planetary bodies were involved in this grand cosmic construction project. Yet only 4 survived the ordeal: Mercury, Venus, Earth, and Mars. This violent scenario prompts a profound reflection on the nature of our cosmic neighborhood. Just how many planets were sacrificed to give rise to the solar system we call home? The answer, hidden in the depths of space and time, is slowly being pieced together, one meteorite, one clue at a time. Astronomers, in their quest to decipher this celestial saga, have crafted radical new theories, each a key designed to unlock the secrets of this cosmic cold case. The Grand TAC model sheds light on the absence of a hot Jupiter in our solar system, while the Grand ATTACK model offers insights into the missing material within Mercury's orbit and the conspicuous absence of super-Earths. These theories are the tools with which we seek to unravel the mysteries of our cosmic origins. But even with these groundbreaking models, the enigma of our red neighbor, Mars, remains a puzzle that demands a unique solution. The architecture of the inner solar system presents a pattern that begs for explanation. From the smallest planet, Mercury, the size of the planets increases progressively, leading one to naturally anticipate that Mars, Earth's outer neighbor, would follow this trend. However, Mars defies these expectations, presenting a conundrum that puzzles even the most astute astronomers. It's a fraction of the size it should be, not the robust world one might expect, but a smaller, more delicate planet. But size is not the only mystery that Mars harbors. Recent scientific endeavors have shed light on the age of Mars, revealing a history far more ancient than previously imagined. A piece of Martian meteorite made its way to Earth, carrying within it the secrets of Mars's mantle. Chemical analysis of this extraterrestrial envoy revealed that Mars formed rapidly, materializing from the cosmic dust in a mere 2 million years after the solar system's birth, long before the Earth took shape. This revelation presents a stark contrast to the slow, methodical formation of Earth, a process that spanned 100 million years. Mars seems to defy the cosmic narrative, its formation too swift, its size too modest. Everything about Mars feels incongruent, an anomaly in the celestial order. These mysteries within the peculiarities of Mars's size and age might contain the answers we seek. Scientists postulate that Mars was not alone in its rapid formation. Alongside it, perhaps as many as 30 other planetary bodies emerged in the nascent years of the solar system. This celestial congregation, a 30-planet pileup, represents a period of intense and rapid planetary formation, a cosmic epoch marked by creation and chaos. But what became of this crowded assembly of worlds? What cosmic events unfolded that left Mars as a solitary remnant of this once bustling neighborhood? The fate of this 30-planet pileup is a chapter in the solar system's history that remains to be fully understood. In this model, the early solar system is a bustling hive of activity, rapidly giving birth to 20 or 30 Mars-sized planets. This assembly of celestial bodies orbits perilously close to its neighbors, teetering on the brink of cosmic chaos, a delicate dance of gravitational harmony and tension. In the infancy of the solar system, a thick veil of gas envelops these planetary embryos, a protective cocoon that maintains the fragile order of their orbits. But nothing lasts forever. After 20 million years, the gas dissipates, leaving the orbits of these Mars-sized planets to intersect and entwine. The once serene solar nursery transforms into a tumultuous battleground, a cacophony of cosmic collisions and celestial upheaval. Over the ensuing 100 million years, this frenetic dance of destruction gives rise to second-generation planets, Venus and Earth, born from these fiery, violent encounters. Yet amidst this cosmic melee, one planet remains a silent spectator, watching from the fringes of the chaos. Mars stands apart, its formation complete, while its siblings continue to grow and collide. This early cessation of growth is the secret to Mars's ancient lineage compared to its younger siblings, Earth and Venus. But what shielded Mars from the fate of its fellow planets? The answer lies with the gas giant Jupiter. During the Grand TAC, Jupiter embarked on its own celestial voyage, venturing to the very region of the solar system where Mars now resides. In doing so, Jupiter unwittingly played the role of cosmic thief, stripping away the material that Mars would have used to continue its growth. This act of cosmic larceny left Mars starved, its potential to become a fully fledged super-Earth unfulfilled, its destiny forever altered by the gravitational whims of Jupiter. While Earth emerged from the wreckage of this planetary pile-up, a silent testament to this turbulent epoch continues to grace our night sky: the Moon. For long, we believed we understood the Moon's origins, but the cosmos delights in challenging our assumptions. An observer from afar would immediately notice the peculiar size of Earth's moon, an anomaly among the celestial bodies of our solar system. Its sheer magnitude defies the norm, prompting questions about its mysterious genesis. The prevailing theory tells of a cataclysmic collision between the early Earth and a Mars-sized object known as Theia. The aftermath of this colossal impact saw debris flung into orbit around the Earth, gradually coalescing to form the Moon. But the exact details of this celestial event, the when and how of the Moon's formation, remain shrouded in mystery, a cosmic riddle that continues to captivate and elude even the most astute astronomers. Each planet, each moon, tells a story of creation and destruction. Since the days of the Apollo missions, when humanity first set foot on the lunar surface, scientists have been on a quest for a lunar relic, a piece of moon rock that holds the key to unlocking the secrets of our celestial companions' origins. Melanie Barboni's team at UCLA is at the forefront of this cosmic detective work, authorized to delve into the mysteries enshrined within these precious lunar samples. However, the path to discovery is fraught with challenges. The Moon's surface, scarred by the relentless bombardment of asteroids and marred by geological upheavals, bears the marks of a tumultuous past. These violent events have left most lunar rocks contaminated and jumbled, their stories obscured, and their secrets locked away. The quest for a pristine sample, untouched since the Moon's formation, is like finding a needle in a cosmic haystack. Undeterred, the team devised an ingenious solution to this problem. Instead of attempting to decipher the entire rock, they turned their focus to a minuscule yet profoundly revealing component within the lunar samples, the zircon crystal. These tiny crystalline timekeepers, smaller than a grain of sand on a beach, are the remnants of a time shortly after the cataclysmic collision between Theia and Earth. As the molten crust of the nascent Moon cooled and solidified, these zircons crystallized, encapsulating within them the secrets of the Moon's early history. Zircons are nature's most meticulous chronometers, their surfaces smooth and unmarred by fractures, resistant to the ravages of time. Within their crystalline structure, they harbor radioactive elements that decay at a steady rate, ticking off time with atomic precision. By measuring this radioactive decay, scientists can unveil the age of these celestial relics. The zircons they discovered have rewritten the lunar chronicles, revealing that the Moon is around 140 million years older than previously believed, its formation a pivotal event in the solar system's tumultuous infancy. This revelation places the Moon's birth amidst the chaotic destruction of the 30-planet pileup, suggesting that Theia itself might have been one of these Mars-sized planetary embryos. This narrative reshapes our understanding of the Moon's origin, portraying it not as the product of a distant rogue celestial body, but as the offspring of a member of our solar system's early family, a planetesimal forever lost to the annals of cosmic history. But the quest for traces of Theia within the lunar rocks yields more questions than answers. Moon rocks bear an uncanny resemblance to those of Earth, sharing the same geochemical fingerprints, the same isotopic signatures. If the Moon were indeed born from a colossal collision, one would expect to find a distinct chemical signature, a telltale sign of Theia's contribution. But the Moon's composition is almost identical to Earth's, save for the absence of heavy elements like iron and nickel, which are abundant in Earth's core. This leads scientists to envision a different scenario: not a head-on collision, but a grazing impact. In this model, the lighter materials, floating atop the early Earth, were splashed out into space by the glancing blow, coalescing to form the Moon. This theory aligns with the Moon's lower density compared to Earth, suggesting it is indeed composed of material from Earth's mantle, a celestial fragment cast into orbit. Yet, even this grazing collision model struggles to account for the Moon's substantial size. To resolve this paradox, scientists propose a series of smaller, sequential collisions, each grazing impact contributing a portion of Earth's crust to an orbiting ring of debris. Over time, this cosmic debris, along with several moonlets born from each collision, gradually coalesced, merging to form the Moon as we know it today. This suggests the Moon's origin is not a singular event, but a symphony of impacts, a series of celestial encounters that gave birth to our lunar companion. The Moon that bathes our world in its silvery glow tells a tale not of tranquility, but of a tumultuous past, a narrative sculpted by the relentless forces of cosmic collisions. The Moon we admire today is not merely a celestial body. It is a survivor, the final remnant of a series of cataclysmic events that once defined the early solar system. It stands as a testament to a time when the cosmos was a crucible of creation and destruction, a time that has since given way to the serene calm we now cherish. Our models and simulations paint a vivid picture of a young solar system, a realm far removed from the orderly domain we observe today. But from this maelstrom of destruction, a period of calm eventually emerged, a stable and hospitable environment where life could take root and flourish, evolving under the gentle watch of a now tranquil cosmos. However, beneath this veneer of stability, mysteries linger, questions that challenge our understanding of the cosmic order. One such enigma is the peculiar tilt of our solar system. The 8 planets orbit in a flat plane, a seemingly orderly arrangement. But when compared to the spin axis of the Sun, this plane reveals an unexpected skew, a lopsidedness that defies simple explanation. The Sun itself is tipped by 6 degrees relative to the plane of the solar system, a subtle but significant deviation that stands as an outlier. The traditional narrative of our solar system's formation speaks of a spinning cloud of gas and dust that collapses into a disk, giving birth to the Sun and the planets. In this model, everything should spin in harmonious alignment, yet the Sun's peculiar tilt suggests a different story, a tale of long-term gravitational tugs and cosmic influences. Could it be that a distant, mysterious planet lurking in the cold outer reaches of the solar system has been exerting its gravitational pull over eons, subtly altering the orientation of the Sun's pole relative to the plane of the planets? This possibility opens a new chapter in our quest to understand our solar system, a journey through the violent chaos of the past and into the mysteries that await in the future. In the year 2016, astronomers Constantine Batygin and Mike Brown stood at the precipice of a monumental discovery, claiming to have found the elusive piece of the celestial puzzle that had long baffled scientists. They named their discovery Planet 9, a theoretical behemoth lurking in the shadowy fringes of our solar system, its presence hinted at but never seen. Planet 9, as envisioned by these celestial detectives, is a world of substantial mass, approximately 10 times that of Earth. It is believed to follow a highly elliptical and tilted orbit, a solitary wanderer in the vast expanse of space. With each close approach to the Sun, this enigmatic planet exerts a subtle gravitational pull on its solar siblings, a gentle tug that over countless millennia could twist the entire planetary system out of alignment with its primordial plane. This distant giant, if it indeed exists, may hold the key to unraveling the mystery of the solar system's peculiar tilt. Yet the story of Planet 9 is not just one of cosmic intrigue, but also of potential cataclysm. As the Sun, like all stars, follows its inevitable life cycle from birth to death, Its transformation into a red giant and subsequent shedding of outer layers will have profound implications for the celestial bodies that orbit it. The gas giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, will drift further away, their orbits expanding as the Sun loses its mass and its gravitational grip weakens. But for the distant and elusive Planet 9, the scenario is markedly different. Orbiting in the remote outskirts of the solar system, this theoretical world may find itself increasingly influenced by forces beyond the Sun's waning pull. The gravitational field of our galaxy, the tidal forces exerted by passing stars, all these cosmic factors could conspire to nudge Planet 9 from its distant path, sending it careening into the inner solar system. This potential shift in Planet 9's orbit could spell disaster for the solar system as we know it. The tranquil dance of the gas giants could be disrupted, their orbits thrown into chaos, potentially leading them to plunge into the Sun or be flung into the cold, dark reaches of interstellar space. In this scenario, the death of the solar system could mirror its violent birth, a cosmic cycle of creation and destruction, with Planet 9 as the harbinger of chaos. In this fleeting moment of cosmic tranquility, life thrives, blissfully unaware of the violent past and potential future that bookend its existence. The discovery of Planet 9, if proven true, serves as a stark reminder of the dynamic and ever-changing nature of our cosmic home. It underscores the fact that our understanding of the universe is still in its infancy, each new discovery a thread in the ever-expanding tapestry of knowledge. As we continue to explore the mysteries of the cosmos, we are reminded of the delicate balance between order and chaos, the thin line that separates the serene present from the tumultuous epochs that may lie ahead. Born in chaos, perhaps destined to end in turmoil, our solar system remains a source of endless fascination.